Hello, I'm Eric Snodgrass, and thank you for watching today's midday weather outlook for the southern region brought to you by Nutrien Ag Solutions. While so much of the attention yesterday was given to the large derecho event, which is just a large damaging squall line that went through parts of Iowa, Illinois, and into the eastern Corn Belt, across parts of the southeast, specifically in parts of South Carolina, getting over into Georgia, we saw some very, very large storms. And also on the tail end of the front that was initiating that squall line that went through parts of the Corn Belt, we did see over here in parts of Kansas, getting into Oklahoma and Texas, some very large storms as well. When it was all said and done, I know that the storm reports that are up there in the Corn Belt kind of dwarf what we see elsewhere around the country, but there were still several reports in parts of Oklahoma and Kansas, as well as Alabama and Georgia, of some very strong winds, and a couple there in South Carolina and Tennessee as well. So this was a rough day across the United States in terms of strong straight line wind damage. Now, speaking of wind damage, we do need to be talking about the tropics. I'm going to take you here just off of the west coast of Africa. And what we're watching here are a few African easterly waves. Now, that's got some terminology that we use all the time in atmospheric sciences and meteorology, but I'd like to explain to you what we're talking about, because specifically we're watching this event right in through here. So you can see this large area of organized convection or thunderstorm activity here in the tropics. And right in through there, you can really see a very well-defined large cluster of thunderstorms. Now, the reason why we watch these so carefully is because of the tremendous amount of heat that's released in the production of these storms. And in the tropical environment, that heat that is released by these storms can lower the atmospheric pressure, which then kind of puts us into a positive feedback loop of developing more of these storms, and they begin to organize and rotate around this center of low pressure, which is again formed by heat. So this is not formed by the jet stream, this isn't formed by other factors, it's just simply heating. Now, what gets them going in the first place really has to do with the way that the winds flow. So if we just kind of come back here to the beginning of this animation, we can see where our tropical wave began, which was right in through here. And what's going on in the atmosphere is that the wave actually looks like this in the pressure field. Okay, so this is not an ocean wave, it's a wave in isobars. All right, now right in through here, if I drew a few of these, okay, right in through here where I just drew that line, in fact, let me make that a little clearer. There's another isobar and there's another one. Right in through this area, there is what we call a trough axis. Now, I know this is different from when I talk about troughs in the jet stream. We're at the surface here. And what ends up happening here is that as the air comes into this trough axis, it comes out fast here and has to slow down right there, and then tries to accelerate out the other side. So if the surface air is forced to decelerate or slow down right in through this area, you get a region right in through here, right there, of convergence at the surface. So if the air is forced to converge at the surface and gather in one place, it's going to rise. When it rises, that leads to cooling, condensation, clouds, and storms like this. So always on the upstream side of the trough axis, which is again this line I drew right here, we have convergence. So we watch these waves in the flow of the atmosphere coming off of Africa, and they are what initiates the development of tropical systems. Now, right now, the National Hurricane Center is giving this tropical easterly wave a 90% chance of development. And if we look here at what might limit it, this is a very quick animation of some of the dust in the Saharan air layer, which is just to the north of this particular system. So it's got some drier, dustier air to work on it from the north, limiting it. But currently, the GFS model's tracking the center of low pressure toward the Lesser Antilles over the next 7 to 10 days. But because of dominant higher atmospheric pressure, which we've been talking about, sitting out here in the open Atlantic, that will help to curl this system around before I think making any sort of issue for the United States. Now, of course, this is a long ways away, and we still have to see if it even develops. But at this point, this seems to be the best strategy moving forward, that high is going to help curl it around. The other thing that helps curl these systems to the north and away from the equator is the Coriolis effect, which is a result of the rotation of our planet. The GFS and the European both paint a similar picture. So here's the European's potential outlay here of the storm and where it's going to go. So you can see very similar setup here. But we need to talk about what's going on right here. While this is not tropical in development, we're looking here at just the development of low pressure somewhere here along the Carolina coast. And that's going to be giving us a very, very wet next week. You see, this is the Weather Prediction Center. So this is part of the National Weather Service. This is their forecast for the next 7 days in terms of total accumulated precipitation. And while the southeast is expecting to be very wet, daily thunderstorm activity plus the development of that coastal low, getting back over to the south central United States, it's going to be a case of hit or miss thunderstorms as a broad broad ridge begins to develop here over the southwestern United States. The European model echoes this pretty well. So that previous map was a blend of U.S. models. This one here is just the European kind of standalone. So you can see the wet conditions and the development of that tropical in nature low that's coming here off the Carolina coast. So back into parts of Texas, getting over toward the Delta. Our chances for storms here are limited to hit or miss. You can clearly see the monsoon is not showing up very well, again, due to the presence of this larger ridge. And so let's take a look at why this is all happening the way it is. In the upper levels of the atmosphere, we have very stagnant flow, and that's coming all the way down to the surface as well. We see that over the next week, wind speeds here, synoptic scale wind speeds, so not from thunderstorms, but just the normal wind flow is very weak compared to the rest of North America as we look out here over the next week or so. And that's because of the jet streams doing this. Strong North Pacific jet stream. See it coming in like this, cutting into the Canadian prairies. We then have our ridge developing over parts of Arizona and New Mexico, so that flow is coming around like this. So what's left is here, there's a large ridge to the north, there's split flow to the south, and the whole thing is just kind of stagnant all the way through the depth of the atmosphere. So that's why these thunderstorms that pop up locally produce extremely heavy rainfall, but they develop very vertically. You go out and watch these storms if you're watching me in the southeast. They'll go straight up, it comes straight down, and as a result, they don't tend to produce long-lived damaging squall lines of thunderstorms like they did here the other day. So just a bit of meteorology here to explain what's going on. So if I were just to play this, what you're going to see here is just pops of green almost every day in the southeast. See that? That's underneath that stagnant pattern, just the heat of the day popping these storms. But there's a bit more to it than that. So going through the day today into early tomorrow morning, there is actually a weak frontal boundary still stretched in through here. So getting up here to where the Ohio and Illinois and Mississippi rivers all come together right in through there, could be seeing some storms coming down here toward Memphis, over toward like Little Rock and south of there. But as we play this forward into the afternoon and evening, there it is. Now you can see those storms popping in that area on that frontal boundary. Playing into the evening on Wednesday, there's the pop-up storms all across the southeast. See it? Up into the mid-Atlantic. As we go forward from there, this is now getting into Thursday morning, Thursday afternoon and evening. It's the same story once again. But generally, there is no front in through here. It's a weak at best boundary. In fact, there's generally higher atmospheric pressure in this area. So it's just popping on the heat of the day. Same thing on Friday. See it? As we work our way into Friday evening. Now, at this particular point, we are watching for the potential for some low pressure to develop somewhere here along the Carolina coast up to Virginia. That's not much, but it shows up, this weak little low that comes racing here off the coast. So this is now Friday night into Saturday morning, Saturday afternoon and evening. And again, just scattered storms in this whole region. As we go from there into the weekend, this is where things start to change up a little bit. Yeah, it's still storms scattered here on Sunday afternoon and evening, but now you can see a much more defined front, and this is showing up in both the European and the GFS that's coming through this area. So now we're talking about better chances at least of getting some storms over here in the panhandles at this time. So as this front comes through, now you can start to see it kick things out. See that? I just went from Sunday afternoon all the way to Tuesday afternoon, and our frontal boundary has moved pretty far to the south. And that's also going to bring in some cooler air. Look at that high pressure setting up over the Great Lakes toward the Hudson Bay. Yeah, all along the southern edge of that is where that front is located. So I just took you out all the way out to next Wednesday morning. Let's go take a look at what that pattern is going to look like by the end of next week. So here's that large ridge that we saw firmly developing here over parts of the southwest. Trough coming into the Pacific Northwest runs over that ridge, and there's still broad troughing here. So this is where that frontal boundary all along its south is going to sit. It's going to be weak, but it'll be there, and that's also going to signal a bit of a cooler pattern. But along that frontal boundary, look at what the precip patterns are going to do. GFS has it wet here, so does the European. It's drier back farther to the west. It's only hit or miss scattered storms as you go west of that particular region for our southern region. But August 18th through 25th, these are the precipitation patterns we're seeing at this point. Now, generally, when I see these values, while I do expect it to be much wetter than normal right here along and south and east of the Appalachian Mountains, elsewhere, we're still going to see daily scattered thunderstorm events over in this part of our southern region. It's just that the southwestern monsoon is substantially weakened as we move here toward the end of August. Now, watch what this does to temperatures. Starting out today, Tuesday, a lot of mid-90s, getting the upper 90s and lower 100s as we get over to Arizona, New Mexico, and western Texas. But as we play this forward, look at the heat coming in here. Watch it again with me. Look at the heat coming in here on Wednesday and into Thursday in this part of Texas, Oklahoma, New Mexico. This is extremely hot conditions for this time of year, well above average, maybe 9 to 10 degrees above average here. As we played into Friday, the heat's still on there, but look over here where the daily storms are popping. We're now seeing these thunderstorms cool the afternoon air. A lot of temperatures here in the upper 80s to low 90s. As we go from Friday into Saturday and Sunday and Monday, we kind of see a very similar thing, but here comes that broader front early next week, which we talked about, cooling things down in the midsection of the country while the west heats up under that large ridge. You can see it in the 6 to 10 day forecast. Both models really bringing the heat into the western United States as that ridge gets developed, and the flow coming out of the northwest, cooling things down from the Corn Belt clear to the southeast. And that seems to be the way things want to be, all the way out here to the 26th of the month. We get this cooler anomaly here, much warmer as you go to the west. Last things I want to show you, latest European weeklies. Now, the European weeklies have had a pretty well-known warm bias for much of the United States. You can see that across the southern region, though, it's got us much closer to average on our temperatures. I put down there a few bullet points that you can pause it and look at it, but it's the same story I've been telling you. It's all about the North Pacific jet stream and what it's doing and how we're not blocking up the Gulf of Mexico. And the other big piece of this is what's going on with tropical cyclone activity. That is certainly going to be something we need to talk a lot about because, as we've been discussing, the MJO is on its way back over here to phase 8, 1, and 2. And should it go back over to Africa, that's going to suppress vertical motion here and allow it there. So it looks as though as we go into the peak of our hurricane season, the atmosphere is much more conducive to tropical cyclone development. So I think we're going to be watching the tropics a lot here in our southern region forecasts. With that, we'll go ahead and stop there. Look forward to giving you my latest long-range update coming out pretty soon. Thanks for watching.